A very good morning. I, Pooja Bisht, Assistant Professor, School of Information Technology, welcome you all to the inaugural session of National Conference on OMNI-LAYER Dynamism and IoT, organized by the School of Information Technology, KCC Institute of Legal and Higher Education. The event is graced by the presence of our chief guest, Padma Shree Dr. Mahesh Verma Sir, Honorable Vice Chancellor Guru Gobind Singh Indraprastha University. Also, we have with us the subject expert from academia, Professor Nishchal Kumar Verma Sir, IIT Kanpur, and subject expert from industry, Mr. PVN Pawan Kumar Sir, Director, SAP India, and Dr. Professor Bhavna Agarwal Ma'am, Director, KCC-ILHE. Now, I request our Director, Dr. Professor Bhavna Agarwal Ma'am, for conference introduction and welcome address. Ma'am.
Thank you, Pooja. Very good morning to one and all present here, and thank you for joining us today. On behalf of KCC Institutes, I welcome our esteemed guest on this national conference by School of Information Technology, OMNI-LAYER Dynamism and IoT 2020. This is our third conference of KCC Institutes for the year. We are privileged and honored to have amongst us Padma Shree, Professor Dr. Mahesh Verma Sir, Vice Chancellor Guru Gobind Singh Indraprastha University, who is always kind to us and has spared his valuable time to be with us. Sir, I convey my sincere thanks and extend our heartiest welcome. We are honored with the kind presence of Dr. Nishchal K. Verma Sir, Professor, Department of Electrical Engineering and Interdisciplinary Program in Cognitive Science, IIT Kanpur. I extend a warm welcome and I sincerely thankful for his benevolent presence, sir. Ladies and gentlemen, we have among us Mr. PVN Pawan Kumar, Director Product Management, SAP Labs India. Sir, we welcome you on behalf of KCC Institute and I'm thankful for your benign presence with us. In recent scenario, the world is focusing more on the latest interactive technology, which includes omni-layered approach in dynamic computation with interactive features in Internet of Things. As the need of connectivity between the devices reached at the next level, it became the most demanding topic of research. The IoT has become a central and exciting research area and encompassing many fields in information and communication technology. IoT systems involve interactive, heterogeneous, distributed, and intelligent things, both from the digital and physical worlds, including the human in the loop. The crux of this conference will be the use of digital technology such as IoT, artificial intelligence, augmented reality, and so on. That is being increasingly adopted after the outbreak of the COVID-19 pandemic. Only by working together, we can develop a better, secure, interoperable IoT ecosystem, one that will build trust and confidence in the technology, bring the maximum possible value out of our fast-growing wealth of data, and open up a new world of possibilities for improving people's lives everywhere. I hope the conference will provide a good platform in the exchange of the information of development and innovation, as well as new collaborations between scholars, academicians, and practitioners. I'm sure this conference will be very Thank you so much.
Thank you, ma'am, for a wonderful opening. Now, I request Dr. Deepti Sharma, ma'am, Coordinator, School of Information Technology, to introduce our chief guest for the day, Padma Shree Dr. Mahesh Verma, Sir, Vice Chancellor of Guru Gobind Singh Indraprastha University. Ma'am.
Thank you, Pooja. A very good morning to all the dignitaries present here. I start with a very good quote given by Brendan O'Brien, a famous writer, producer, and a music engineer. He stated that if you think that internet has changed your life, think again. The Internet of Things is about to change it all over again. It is indeed a lot to introspect on. It is my proud privilege to introduce Padma Shri Dr. Mahesh Verma Sir, Vice Chancellor of Guru Gobind Singh Indraprastha University, Padma Shree Dr. Mahesh Verma Sir, an Indian prosthodontist, the Vice Chancellor of Guru Gobind Singh Indraprastha University, is a graduate from dentistry from Government Medical College Trivandrum and secured his master's degree MDS from the same institution specializing in orthodontics. He was conferred by Government of India with the Padma Shri, the fourth highest civilian award for his contribution in the field of medicine in year 2014. He is also a recipient of Dr. B.C. Roy National Award, the highest national medical award in the year 2007. He has been facilitated by multifarious awards, including fellowship from many national and international organizations and academic bodies. He has been involved with many professional and academic organizations. He is the president of International Association for Disability and Oral Health and the Indian Academy of Restorative Dentistry. List of his credentials is very long, and his presence in this conference is adding value to the contributors. Now, I request Padma Shri Dr. Mahesh Verma sir to enlighten us with his words of wisdom. Welcome, sir.
Thank you, Pooja. It's wonderful seeing all of you. In fact, I'm attending a conference, conference after a long, long time, and uh, primarily because of Bhavna, who insisted that I be amongst you. So, Professor Bhavna Agrawal, Director of KCC Institute of Legal and Higher Education, uh, our keynote speakers for today, Professor Nishchal Kumar Verma from IIT, and our industry partner, Mr. Pawan Kumar from SAP. Uh, we have Sunita Singhal, Rapporteur, Deepthi Sharma. We have also Tina, others which I can see here on the dashboard. And the dear students, faculty, ladies and gentlemen, I'm truly delighted to be amongst you this morning and wish to congratulate you for arranging this wonderful conference. As Bhavna said, that this is the third one in this year. And I know you've been focusing so much on IoT, AI, and things like that. Last time when I was amongst you, the topic was very similar. And, I think this is really needed in the current times, as that entire world is looking that how we can harness technology, which can safeguard our future. We are all, grappling in dark, and all different vaccine companies, they are trying to see how the technology can be utilized so that, we have the answer. So, we all realize that the human civilization has really grown exponentially. If you look at the numbers today, we are almost 8 billion on the planet. And our brains are also evolving. Today, if you look at a small child and you compare it, that, baby which was born 20 years back or 30 years back, you find babies are born with sharper mind, sharper brains. I look at my grandson, every day on a video who's in US, and I really wonder that all these children which are born today are so much precautious. They are much more smarter. So our brains are evolving, and our brains are becoming complex, improving our intelligence, and we know that human beings have that supremacy, which is uncontested, that we know that we can rule the world. And also our, the way we are consuming, our consuming pattern is also changing, isn't it? If you look at today, people of all nations, they want to feel and yeah, they want to feel and act younger than their age, isn't it? And we are. Don't you think that we are living much longer? And when India got independence, our life expectancy was just 37 years. And today it's about 67, 68 years. And ladies are living longer. So so we still want to look, even at that age, we want to look younger. And our conscious consumption of personalized experience is more sought after than mass produced material goods. Anything we want is a custom made for you. When you go to when you want to buy a dress, it has to be a designer dress, because it has to be specially made for you, isn't it? And also the way we eat is also changing, isn't it? We're becoming more vegan today. We are more conscious about eco-friendliness, isn't it? We never bothered for all these things, all these years. And what is really changing us is digital, which is opening the way we interact, the way we live, way we behave. And also specializes is being overemphasized. You becoming from specialist, you're becoming a micro specialist. And we all realize today that knowledge is power. There's nothing bigger than knowledge. And you also, the practicalities of working from home, this is a new norm. Never ever we realized that we could do things from home, and we really don't have to go to offices. So these things are surfacing. So these are some of the trends which is happening all across, and humanity is witnessing, not only in this part of the world, but all over. And if you look at India, India's story is no different. Our country is a treasure mine of opportunities. Even after taking a hit after the COVID pandemic, India's geostrategic position and massive market size has the potential to provide a stellar future for India's future generation. I know it has taken a hit a little bit, but still, we are really going great guns. As we stand today at the cusp of a digital future, because that everything is getting digitalized today. So we are at the cusp now, and it is the time to ride. We must mature now to speculate on many opportunities that the 4.0 industrial revolution, which is offering, and which will inspire us. Our country has unlocked the potential of digital technology, and as of 2020, the penetration of internet in India is about 50%. So 50% of our nation is already digitalized. And of course, this this percentage will continue to rise. And we know that more and more Indians will join the World Wide Web. So India is one of the largest and the fastest growing market for digital consumers. And I don't have to tell you that our own Aadhaar, it is the largest digital ID program that has been run by any country in the history of the world. And all citizens of digital India now, as we are getting digitalized, every person has a digital access. So all the citizens now, they are subscribing to the idea of collective progress, so that we all progress together. And so what is that? That is the data. The data that our physical world generates is collected, it is collated, it is analyzed, and it is interpreted to be used for our growth and prosperity. We all creators of data. All of us are creating data, isn't it? And we as a collective should realize the value of our bodies and our minds. I come from a medical background, as Pooja was just telling my background. She didn't tell me that I was a dean at Maulana Azad Institute of Dental Sciences for almost 34 years. And I built it brick by brick. So my medical background, tells me that there is an unbelievable amount of data which our body is creating involuntarily in a day, even while you are unaware of it. We don't know how much data our body is generating. I'm sure all of us have a smart watches today, or we have those Fitbits, which we wear and we do some physical exercises, or we have a Google Fit. It knows how many times your heart is beating in a minute, and it is keeping a surveillance of all types and degrees. So as a norm, so to consumers, this sure does sound risky. For instance, imagine a scenario where a pharmaceutical company collect this data, all this data of a population, but instead of finding solution to the health problems, they get focused on increasing their sales or profit margin For the consumer, this is a death trap, but for the corporation, for the pharmaceutical company, this is a gold mine of human capital. So this is how, this is what we have to be careful about. You have seen how these corona vaccine companies across the globe, they are vying with each other to be the first one. And many a times in this rat race, in order to become the first one, sometime they can play with data, isn't it? All those, you're talking, you must have heard that phase 2, phase 3 clinical trials, and they have to show evidence that nobody had, I mean, the effectiveness and complications, it is effectiveness, its sensitivity and specificity, all those parameters. So sometimes in order to jump, many a times things can also be looked overlooked in a haste. So some experts may say that the unauthorized selling of data should be illegal. It may sound paranoid at this moment, but there are markets that have been labeled illegal for centuries. Dealing in human organs is illegal. Slave trade is illegal. And the snippets of data that tech giants collect about us, or using any portion of that without our knowledge, is not a good way to do business, even for the tech giants. And I'm sure you all know that how data is collected through our smartphones and Alexas, which you have in your house. So they all the time they are hearing to your conversation, they are collecting the data, and without our information and knowledge, isn't it? So this is a platform that will discuss technological possibilities of what can be developed, and that is great. This is that is the future of humanity. However, at the same time, it is absolutely essential to raise ethical concerns about what we may evolve to become. As a process, evolutions trumps revolutions, and evolution trumps development, and evolution trumps technology. So all these things, when evolution happens, all these things, revolutions, it overcomes revolution, it overcomes development, and it overcomes technology. For the survival of our species, human race, it is essential that we take repercussions and projections into cognizance, so that we do not increase our suffering. I hope your national conference like this will also, sometimes start a conversation about what it means to create a future where the human race is free to chase progress, so that we are chasing progress, at our own will. And technologies are short at escaping the dystopia. The entire world may be going through great suffering, injustice, and we use this technology to overcome that and freeing our civilization from the shackles of unrest. You've seen that there's so much of unrest and so much non-peace across the globe. And I'm sure such a brainstorming like what you talking about, IoT and cold date and blockchain technology, all this, what are your topic of your conference, would be constructive, and we will have we will and it will pave way for a brighter world. Basically, all these technologies, all these all these newer areas have to have applied for, and ultimately it has to serve the humanity in a very ethical way. I take this opportunity to thank the leadership of KCC Institute of Legal and Higher Education, especially its director, Professor Dr. Bhavna Agarwal, for organizing this program and encouraging all the activities which is happening around the year, and also it gives a KCC an impetus to stay relevant and focused. My best wishes to all of you. May you find success in all your future endeavors. Thank you, Dhanyavad, and Jai Hind.
Thank you, sir, for your kind words and emphasizing on collective progress in this technology driven time. But at the same time, raising ethical questions is also our responsibility. So, thank you so much.
Thank you, Dhanyavad.
Moving further, now I would like to take this opportunity to introduce Dr. Nishchal K. Verma, sir, subject expert from academia. Welcome, sir. Dr. Nishchal K. Verma, sir, is a professor in the Department of Electrical Engineering and Interdisciplinary Program in Cognitive Science at IIT Kanpur. Sir has obtained his PhD in Electrical Engineering from IIT Delhi. He is an awardee of Devendra Shukla Young Faculty Research Fellowship by IIT Kanpur for year 2013 to 16. His research expertise falls under artificial intelligence related theories and its practical applications to many interdisciplinary domains. He has also published more than 230 research papers and 4 books in the field of AI. He has successfully completed 23 projects from various funding agencies such as the Boeing Company, USA, DST, DRDO, and many other reputed organizations. He has 15 plus years of experience in the field of AI. He has been serving as associate editor, editorial board member of various reputed journals and conferences. He has also developed several AI related key technologies for the Boeing Company USA and has also organized AI related workshops, conferences, seminars, short term courses, etc. Without any further delay, I would request Dr. Nishchal K. Verma, sir, to kindly address our audience. Sir.
Thank you very much, Pooja ji.
Thank you, sir.
Is this the address only or the keynote? Address along with the keynote. So should I consider that this is the full lecture?
Yes, sir, you can go ahead.
Okay, thank you. Thank you. So can I share my PPT?
Sure, sir. Sure.
Yeah, so could you please enable the screen sharing?
Yeah, sir, just give us a minute, sir.
Sure.
Yes, sir. It's done.
Right. So I hope the slide is visible.
Yes, sir, it's with.
All right. Okay. Okay. So first of all, I would like to thank Professor Bhavna ji, Director KCC Institute, for inviting me on this forum to share Internet of Things related issues and especially the kind of things that we are having right now. When we say things, this means the devices, right? And how these are connected in order to collect the information, and more on this I will be coming to. So Padma Shree Professor Mahesh Verma ji, Vice Chancellor, Guru Govind Singh in Trust University, Professor Bhavna Agrawal ji, Director KCC Institute, keynote speaker Dr. Lavnish Chanana, VP Government Affairs, Asia Pacific and Japan, SAP. Professor Pooja Vest, Professor Deepti Sharma, Professor Tina Raj, and other faculty colleagues and their students. So I would like to kindly welcome to my talk on Internet of Things. So I guess this talk, I am supposed to discuss few of the technical points here, because without that, it will be very difficult to talk about Internet of Things. So let me first tell you that the engineering name, the technical name of Internet of Things is cyber physical systems, right? So you can relate it with the internet. See, the cyber and internet both are related, right? So Internet of Things, and the engineering name, the technical name of Internet of Things is the cyber physical systems, which I'll talk about. All right, so let us now quickly look at the Industrial Revolution. I will take you to that era, since when the industrial setups have started or came into being and till now. And then I will relate what we are doing nowadays, right? How is it relevant to all this, right? So it starts, you see, in 1760s to and then up to 1840, right? So the first industrial revolution, this introduced the mechanical production, right? And all these productions were machine powered, basically, right? And this power was from where? The water and steam only. There was no electricity that time. And this was termed as Industry 1.0, right? So Industrial Revolution started in the year, year 1760, right? So this was end of 18th century, right? So this is so interesting. And then afterwards, right, what happened? This in second industrial revolution, when the electricity came into picture, right? So after the electricity came, right, so electrical energy was utilized to power the most of the machines in industry. So like these industries were basically introduced with mass production lines powered by electric energy, right? And this gone up to 1940. It does not mean that the electrical energy is not being used, but you see more advanced systems, like electronics and all, IT have come, right? So, but here only basic electricity energy, right? Energy powered machines were running, and they were helping us in mass production, right? So this was the Industrial Revolution 2. Then, and it has gone up to 1940 around. So 1940, right after the third Industrial Revolution, where we have had lots of electronics and IT related stuff that gone added. And especially I would like to tell you, at this time the birth of AI, the artificial intelligence, was gearing up, right? I mean, it was coming into being. So it was 1937 when you see the first computer, right? The Allen's, you must have Alan Turing, you must have heard about Alan Turing's machine. So that actually was conceived that time in 1937. And then another landmark was that time was 1942, McCulloch and Pitt. See, one was the doctor and other was the engineer. Both of these basically studied as to how our brain works, right? I mean, what is that which is helping us to learn and gaining the intelligence? Okay, so all these developments have had that time. And then you see, this was basically termed as Industrial Revolution 3. And then it, of course, continued till 2010. And then you see, although the this IoT, right, or the interconnection of the things, right, the network of things have came into picture in 90s itself, right? But the use of this this network, this Internet of Things, actually helped industries in gaining the industrial revolution, right? That termed as Industrial Revolution 4, right? And here it's written as, you see, the Industrial Revolution here, Industrial Revolution 4, and it's written here as cyber physical systems. So cyber physical system, as I mentioned, is industrial, is basically engineering name, and IoT and cyber physical names together, they can be interchangeably used, right? So you see, what I was aiming to mention here is this, that how the AI, the IoT, right, is helping in Industrial Revolution 4.0, and which is being continued, right? And I will discuss the how AI, artificial intelligence, is also associated with Internet of Things, right? So as of now, what I understand and what we understand is that it is part of Industrial Revolution 4.0, right? And this is being continued. And this started around 2010, right? And it is being continued. So this is very important feature. This is one of the very important features. So let us quickly discuss the building blocks of Industry 4.0. So as I mentioned, you see here that Internet of Things, the Industrial Internet of Things, or Internet of Things, is one of the building blocks of 4.0, of course. And you see one more block is AI and data analytics, right? So I'm sorry, is the screen visible or it has changed?
It's visible, sir.
Okay, thank you. So you see here the you see here the Industrial Internet of Things and the AI, and both of these are helping greatly to the Industry 4.0. And when we say Industry 4.0, basically we are aiming towards automating the industries, right? So we are achieving the greater levels of the automation of industries. So not only in industry, but as was mentioned by, Padma Shree, Professor Verma ji, that we are generating huge amount of data, through biological setups, right, that are placed, the sensors that are placed, and to monitor health of the human beings or even otherwise, right? All these data is coming up, and we need to gain the knowledge out of all these data through data analytics, through AI, right? And of course, this data is going to be a very big data, right? So we need big data analytics. So all these are building blocks. I'm not going to discuss each of these, but you see, these are the Internet of Things, and then AI, artificial intelligence. These two are the main constituents of the Industry 4.0. So you see how important this IoT or cyber physical systems are, AI is, right? So let me quickly go to the IoT, right? So IoT, as I already mentioned, that you see the technical name of IoT is cyber physical systems, and you see here that it has three main components: the computation, control, communication, right? So a cyber physical system is a system of collaborating computational elements controlling physical entities on network, right? So CPS entities are physical and engineered network systems whose operations are monitored, coordinated, controlled, and integrated by a computing and communication core, right? So they allow us to add capabilities to physical systems by merging computing and communication with physical processes, right? So what are the benefits at this moment here is that these are safer and more efficient systems. These reduce the cost of building and operating the systems, build complex systems that provide new capabilities, reduced cost of computation, networking, and sensing. And these the CPS, the IoT enables, right, national or global scale of CPSs, right? So these the local networks. Okay. So let us, in layman's terms, understand the Internet of Things, which is the network of physical objects of things, any like our mobile, right, cell phones that are connected to the main network, and this is further connected to all these cell phones, right? So this is also one of the kinds of internets, right? And so we can say that IoT is the network of physical objects or things embedded with electronic software, sensors, and network connectivity, right? Which enables these objects to collect and exchange data, right? Our objective again is, to control, right? Finally, whatever we are sensing in terms of its data. So IoT allows objects to be sensed and controlled remotely across existing network infrastructure, creating opportunities for more direct integration between the physical world and the computer-based, and resulting in improved efficiency, accuracy, and economic benefits, right? So once again, the things here is nothing but the devices, right? The devices that are in connection or on the network. So things in the IoT sense refer to a wide variety of devices, such as it could be any sensor that could be used for condition-based monitoring of machines, or it can be the same sensor, the device could be used for monitoring the condition of the health of human beings or whatever, right? So we can have multiple sensors as things, we can have multiple devices as things that collect the data, and further it is able to, control whatever, through the actuation. So basically, this is an electronic device, I would say, in layman's sense, and which can, transmit the data and receives the data based on the on the network, and based on certain sensing and actuation, it completes its task, right? So these devices collect useful data with the help of various existing technologies, and then autonomously flow the data between other devices, right? So let us quickly go through the history part of it, right? How did it, came into being? So you see, Internet of Things first became popular in 1999 through the Auto ID Center at MIT, Massachusetts Institute of Technology, right? US. So, and related market analysis publications. And basically, you must have come across the term RFID, which is nothing but the radio frequency identification, right? RFID is very popular. So radio frequency identification was seen as the prerequisite for the IoT at that point. But now, that is not the mandatory element of, the IoT circle. So if all objects and people in daily life were equipped with identifiers, computers, and that could manage and inventory them. So like that. So besides using RFID, the tagging of these may be achieved through such technologies as near field communications, barcodes, QR codes, Bluetooth, and digital watermarking, right? So nowadays, even if we don't have RFID, we can, even otherwise get these devices connected, right, through other networks. Okay, so how it works, let us quickly go through. So Internet of Things involves, you see, several complementary technical developments that taken together help to bridge the gap between virtual and physical world, right? So the major capabilities of IoT include the communication part, how these devices which are on the internet or the network, how do they communicate, right? How do they exchange the data? And then how can they be identified, right? This means the identification part of it, the address of it, address of each of the elements, each of the devices, the things, right? Electronic things. And then, of course, how are these devices are involved in sensing the different parameters. Let's say we have the wireless sensor network, right? That is also kind of internet of things, right? And the things here is nothing but the device, the sensor part. So how is it sensing? It could be, let's say, the temperature, it could be the pressure, it could be humidity, or any parameter, right? So sensing part of it. And then, of course, after all, right, like we have the data sensed, and then based on our objective, how actually are we actuating the control parameter, right? Finally, so actuation is another very important part. And then, of course, the control algorithm, right? Based on that, the actuation happens. And yes, we have lots of data getting collected. So the processing of this data means the data analytics, then localizations, where these sensors are placed, the relative location, and then, of course, how are they interfacing with other devices, right? So all these are very important parameters. And when we want to know how it works, so as I already mentioned, right, it has enormous applications, and depending upon the kind of application these devices, they should have the capabilities, and as I have mentioned here, right? So the structure of the IoT, right, could be like this. See, the IoT can be viewed as a gigantic network consisting of networks of devices and computers connected through a series of intermediate technologies, where numerous technologies like wireless connections may act as enablers of this connectivity, right? So what are the main components? Once again here, the connecting things, right? This means the network. So real-time items, traceability and addressability this provides. And then feeling things, right? So this means the sensing and then the actuation, right? So sensors act as a primary device to collect from the environment, and then shrinking things, right? Miniaturizations. We may have a lot of a big network, and then we need to optimize this network in order to improve its, let's say, connectivity, or maybe complexity, and so on. And then we have thinking things, then the AI comes into picture here. So embedded intelligence in devices through sensors has informed the network, the connection to the internet. It can make things realizing the intelligent control. So intelligent comes, when we use the agents of intelligence, artificial intelligence, and we further, get this implemented. So let us quickly go to the current status and future prospects of IoT. So you see how the world population goes here, see here. And as of now, in 2020, we have 7.6 billion populations. And now you see how these connected devices, how they are getting added up. So currently, you see we have 50 billion of devices, right? Such devices. which are termed as the things, the Internet of Things, right? So things means which are in the net, on the network, right? So you see the connected devices per person, the number of connected devices per person from 2003 to now, you see it is going up. In 2003, it was 0.08, and now we have 6.58, right? So the connected devices have gone very much up, and now it is going to go further up, right? So you see the increase is kind of exponential, right? So we can expect how much data we are going to accumulate. And to deal with data, we have the big data again, the big data area, which is also growing up, and that also includes lots of data analytics tools and all, right? So IoT as a network of networks, we can think of like we have multiple sub networks, and then as a whole we have the internet, and we can say that the Internet of Things is nothing but a network of sub Internet of Things, right? So it has the individual networks, then connected. They are when they are connected together, they also have some network, and then of course there are some features again associated to it, like security, analytics, and there are so many, right? The data management and all, right? So let us go through the benefits, right? So what IoTs are doing, and what is that which we are getting out of doing all this. So here we have the details, which is from GE, General Electric, right? So the industries are listed here: aviation, power, healthcare, rail, oil and gas, right? So in these segments, right, you see the commercial segment and type of savings that is done. And how these savings are done is, you see, by minimizing the waste, right? So the estimated value over 15 years, right, is $30 billion in aviation only. So if we can make use of Internet of Things, right? So you see, we can get lots of saving, or we can minimize the expenditure, I would say. So this further can go up and up by involving the technologies which are further helping in processing the inside mechanisms, and solving various issues that IoTs are facing. So IoTs are helping in almost every facet of life, not only industries, but here you can just see that how much benefits that we are gaining over, and by utilizing the power of IoTs, right? So you see the the value is in billions, and so these are only a few, but there are places where we cannot even compare this, the gains, the advantages, the benefits that can be compared in terms of money, like social sector and all. Okay, so you see, let us quickly go through some of the applications, right? So like Internet of Things, how these are helping, right? In building and home automation, like Alexa was talked, right? And like Alexa, we have so many other apps that are available, and these are helping in our day-to-day life. So building and home automation is one, then manufacturing sector, and then medical and healthcare, of course, right? Where we have lots of devices which could be further interconnected to exchange the information, and for better treatment, better care. And then media is another sector, and then environmental monitoring. Of course, we can monitor pollution, we can monitor rainfall, etc. at various places. And infrastructure management is another one. Energy management, transportation, better quality of life for elderly, which is also a very important area. So let me quickly go through the automation hierarchy when we talk of industrial automation, right? So we see that at the top we have administration, then enterprise, then manufacturing, and then we have supervisory, right? Group control, and then we have unit control, field, sensors and actuators, primary technology. So earlier what used to be before IoT, you see all these were not very much, or I would say efficiently connected to have better productivities. But now what is happening at each and every level, right, on individual basis, these devices, which we call as things, right, Internet of Things, are connected to exchange the information. So in terms of sensing as well as the control before the actuation, right? So all these are happening to have the better productivity, right? And when we say better productivity means in industry, basically the maximizing the revenues, right? So so in order to have better productivity, if our network, right, or the things that are deployed in the industry, if these are efficiently connected, right? So these of course is going to give us the better productivity. And you see, in India, we are very late in deploying these sensors in industries. So I remember when I was working with Boeing company in US. So they started with network-enabled manufacturing even 15 years before, right? Even little much before, 15, 16 years before, right? So then that time people were not very receptive. But now you see these, when this IoT has come into picture, this network-enabled manufacturing, that really further, after utilizing the power of IoT, it has gone way far, and in terms of increasing its productivity and revenues, right? So we see nowadays, how these electronic things, electronic gadgets, all of these are interconnected together, even right from the top to bottom, to share the information, and based on that, how efficiently things are being done in industries. Okay, then we have the efficient waste of another application, efficient waste management in smart cities. Like if we have sensors everywhere, right, all around, and then they can exchange the information as to how these can be tackled, right? Like if the garbage bin is, let's say, full, and then this needs to be collected by the garbage collector. So this information, if automatically goes, so like all these garbage bins can be accordingly managed very efficiently. And not only this, even the transportation system, right? And this is once again, in smart cities, various places, this information, if exchanges are happening through the network, this can very well be very well help to manage the waste and in the city. And then you see in our day-to-day life, we see that how many steps have you walked today? Almost everyone is going through, whether it is a mobile or maybe the Fitbit or whatever way. So everyone is more conscious about the health benefits. And you see, what is this? This is also Internet of Things, right? Your mobile is also Internet of Things. So you see, it is almost all the time, if you have been wearing this. So your sleep pattern and other even components of it could be very easily monitored, right? And based on that, you get suggestions and all. So you can, you see how the Internet of Things is helping us in our day-to-day life. So this way, we can know where we are going and where we have interacted with whom we are interacted with, how long we spoken to a friend, how long we have stopped to a place, inactivity and all. So like that, we know so many things, even whether knowingly or unknowingly. Okay, so these are here, you see. So this as Internet of Things is helping us greatly, right? So Internet of Things is the next stage of the information revolution, right? So after industrial revolution, you see, inside this, the information processing, the Internet of Things is the next stage of the information revolution, and referenced the interconnectivity of everything from urban transport to medical devices to household appliances. Integration with the internet implies that devices will use an IP address as a unique identifier, right? So objects in the IoT will not only be devices with sensory capabilities, but also provide actuation capabilities, as I mentioned. For example, bulbs or locks control, right? You can control the lock over the internet. So like that, we have so many benefits, so many advantages of using the devices on the network. All right. So the additional examples of sensing and actuations could be, reflected in applications that deal with heat, electricity, energy management, as well as cruise assisting transportation systems. Other applications that the Internet of Things can provide is enabling extended home security features and home automation. So nowadays we see, even if we are in the office, and if the child goes to or if somebody else goes to home, or maybe another room or office, so you can, on the being given on the internet, you can use your mobile phone and you can open the door or the lock. So all these are really, not only this, but if you would have used Alexa, right? So you would have realized how beneficial it is, right? This can almost help us as if it is a companion, right? So it can order food for you. It can even schedule multiple jobs if you have accordingly, right? So like that, you see, these devices are in day-to-day we are helping, and further the use of these devices are going to be huge and huge. Okay, so technological challenges are also there. So nothing comes for free. The scalability is another is a very important issue, right? If, let's say, we have a network of things, and we have, let's say, set up a network of things or Internet of Things at local level, whether can it be scaled further to a bigger network? So that is always a challenging task. And then standardization. So unless we have the standard of connecting the standards of connecting the devices, means the communication protocols, the devices that are being connected, these should also be have the standard, the devices. Like, for example, a very simple application, if I take, nowadays the cell phones are coming with C charger, C port charger. Earlier it was the micro USB kind of port of charging, right? So again, this standardization must be also taken taken very seriously, and of course it is being done. So if we want to further solve the issues that multiple countries are facing with the devices that are being connected. And there are, when we go to industries, we have OPC, another, the optical, the open protocol of communication, right? So where the machines are communicating, and then interoperability, and then complexity, and of course the data volume is huge, and its interpretation. All these are really very, very challenging. And of course, the research community is already involved and working. And then comes the criticism and controversies. So many of us, many times, face this criticism and controversies, like privacy. of course, the data is on the network, and everybody, let's say, everybody is very, very scared of getting the data shared, right? So security becomes very important, right? And that's how the cyber security, the network security is very important. So privacy, then security, then autonomy and control, right? Nobody else should be getting the access of the data and control of the data, right? Or the mechanism for which the data has been generated, right? And then the social control, of course, and then political manipulation, environmental impact, influences human moral decision making. So all these points are there. And of course, but within that, the IoT is the use of IoT is used, and it is benefiting our overall society, right, in terms of its engineering use, social use, and other places. All right. So with this, I would like to stop here. Thank you very much. If you have any question, I will be happy to take up.
Thank you, sir, for that insightful sharing about the technicalities associated with IoT, which comes from cyber physical system along with the history of it from the time of industrial revolution and the association of AI and IoT. Further focusing on current and future prospects of IoT and how its potential and applications can make it the next stage of information revolution. So thank you so much, sir. And we definitely have few questions from our audience.
Sure, please.
First thing, thank you so much, sir. The session was really very informative and knowledgeable. So there are a few questions, so I'll just start with it. What are the security concerns related to IoT? Is the present security infrastructure enough to handle the data security requirements of IoT?
Right. Yeah. Very good question. Actually, you see, present security. See, security features are never enough, right? So whenever we develop the algorithm to secure the data, right, we do that. But at the same time, people who are behind, they are also searching for the algorithms which could, breach the security. So this is like, keeps going, and this is endless, right? So, but yes, we keep trying to secure our data, and we keep trying building better algorithms. But after a while, we see that we get this breached no matter what we do. But then we need to be ready for going up and up in terms of securing our data.
Right, sir. That was so nice. Thank you so much, sir. So my fourth question, second question to you is, what features are included in iOS for IoT devices? Further than physical improvements like rugged chassis, resistant, etc., are there any featured focused on IoT functionally? Can those devices interact with the device using Modbus or any other control protocol?
See, basically, when it comes to IoT, right? So IoT is the network, right? A network of the electronic items, electronic things, electronic systems, right? But then, as I mentioned in one of my slides, that we need to have several complementary technologies, and which itself is a branch of engineering, right? Like security, control, sensing, actuation, right? So all these are like sensing. If we talk, it's instrument, you need instrumentation, right? Proper instrumentation, measurement and instrumentation. Then when it comes to actuation, again, this requires electrical, mechanical, electronics, computer. So all these, so that's what I'm saying, right? So here, this IoT is just a physical infrastructure. And then the brain of it lies into multiple disciplines. Okay, so no single branch can help us in to deal with several issues that the IoT is facing. So it gives us the physical infrastructure, and yeah, up to some extent the softwares are helping, like its brain. But of course, you see, all these issues are being tackled up, and see, many of the things are the application specific, like you mentioned, iOS, right? So there also, it depends in what way their protocol, the communication protocol they are adapting, they are using, and then what sensors they are using. So it depends again up to how they are adding these devices up on the network. I hope I have answered your question.
Yes, sir, you explained it so well. Thank you so much, sir. So my next question to you is that IoT is great, but it does create a serious risk in terms of security. I look at IoT as entities that in the past were 100% autonomous, are now gifted as TCP stack and a software interface. As you can see, that creates a huge risk, as all these entities now become accessible to anyone who has legitimately or illegitimately gained access. So, who knows, in the unforeseeable future, pacemakers will become part of IoT. I know that IoT is not going away, but we should not be naive about its risk either. So, this is how do we
Yeah,
see it.
so exactly. Yeah, you are right. So see, that is actually the security part of IoT. See, you have built a house, right? But then there are other aspects of it, right? So IoT is like building a house, right? But then how you have to secure is you have to go to the cyber security part of it. So that is a separate branch, and there also you see, as you mentioned, TCP/IP and all these protocols. Nowadays, up to great extent, we have been tackling these issues. But as I mentioned in the beginning, that you see uh, those who want to breach, right? They are also consistently they are working on it, right? So it's a kind of rat race. So this can never be solved. Okay, but yes, up to some extent we can manage, but we need to be ready for those breaches, and before they make the algorithm, you should make the algorithm not to be breached, and that's what is cybersecurity doing.
Yes, sir. Thank you so much, sir. You explained it really very well. Thank you, sir.
Thank you. Any further questions?
Yes, sir, I have a question. Are there any kind of specific antennas for the things to communicate in IoT?
No, I see. Yeah, so you see, that is the communication part of this IoT, right? So what we are talking here is the network of devices, right? It could be either through antenna, either through other means, like they should be either, it could be wired as well, like on LAN, they can be on the LAN. So that is one way of connecting, right? Through antenna, right? So through antenna is one, like your mobile phone is connected through antenna, right? Cell phone is connected through some antenna, right? Similarly, if I have, let's say, if you see the in industries, there are some devices which are connected online, even in your university, let's say KCC, right? Here also, all of your computers must be on the LAN. So these are also Internet of Things, right? So here we don't need any antenna. Here, this is on everything is on LAN, let's say. I'm not talking of the wireless thing, right? But if it is wireless, of course, you need some antenna. So that is actually ways of connecting or interconnecting things. But that is not necessary always to have IoT. That is one way of doing that.
Fine, sir. Thank you, sir. Thank you very much.
Thank you.
Yes, sir. I have one more question.
Sure, please.
How will the Internet of Things impact the sustainability of the business, and will it have any impact on the environment?
Good question. Yeah, so we have seen multiple examples, and where we have had more stress over the industry part. But when we see the business, what is business basically? Industry is also a business, right? So when we talk of industry, what is industry? Industry is a business entity or economic activity, right? So without the profit, there is no industry. Nobody would like to have any industry without profit, right? So if we take that analogy, so what we do basically in business, in industry, what we do, we are always intended towards increasing the productivity. And when we say productivity, it's an engineering term again, right? Productivity means we are interested in maximizing our profit, right? By all means. So how do we do that? So you see, it's a kind of like if we have a machine, right? And this machine is running for some time, and this machine, let's say, is going into the breakdown, right? So if the machine is going into the breakdown and we are not aware, somebody will come to you and say that, oh, my machine is not working. You are wasting the time. And then when the machine is gone into the breakdown, then you will send somebody to call the mechanic, and the mechanic will come, and then he will say, okay, we need this part and all. So all these will waste a lot of time. And you see, this downtime will not only the downtime, which is when the machine is not working, the downtime will hamper the productivity, you see. And if we have the sensors attached to machine, sensors attached to the operator, sensors attached to the other places wherever whatever is in line. So what we will have right now think of the scenario when we have the Internet of Things. See, nowadays machines are connected with the devices and the monitoring devices. The monitoring device will immediately tell us the status of the machine, whether the machine is working fine or not. If the machine is working fine, the operator will keep working on it, and we don't have to worry at all. But if the machine is, let's say, going into the breakdown, before going into the breakdown, right? If you know a priori that my machine is going into the breakdown, you can call the mechanic that, look, the machine is not, machine is giving some symptom, and you should be ready. Then the mechanic or maybe the engineer. So engineer will be ready with all the inventory items that are needed to be used for that machine. This is a very simple example I'm taking, right? So you have saved time, right? And when you have saved time, it means you are saving the breakdown time. So you are, without even going into the breakdown, you are repairing the machine. Maybe in the night itself, you can repair the machine, and tomorrow it is working fine. So it is not reducing the productivity. Not reducing the productivity means we are increasing the productivity, right? So this is a very simple example. Likewise, you see how are you going to call the mechanic? You have the mobile phone. It's not like you are writing a letter to him, or you are making the phone call, landline. Why? Because that operator is having a cell phone, right? And everyone is, even while sleeping, keep the mobile phone nowadays, right? Even night also, when they get up, they see, is there any message? Is there any call? Is there, like that. So you see the kind of devices that we have nowadays, and we all are, because anytime I can get an emergency message. So my point is that you can save a lot of time by just, by employing these devices. So you can call quickly the mechanic, you can call quickly the engineer, you just WhatsApp, and you get the inventory items. So you see how the business gets affected, right? Affected in the positive sense, right? So how these break down time here in industry. And if we talk of any other business, let's say, right? You can quickly, if you need this order, right, of item, you can quickly WhatsApp and the order is available. So within minimum time, within less time, you get more profit. So that's how these Internet of Devices are helping us in our business. So this is number one. Number two, we had some other question. You had some other question. I think half part of was some social concern, I guess. What was this? Can you repeat it?
No, sir, no social concern. Is the impact on the environment only.
Environment. Okay, okay. Yeah, yeah. So in environment also, you see, nowadays, you see in Delhi, you would have seen lots of sensors are there, right? Like air quality sensors and so many other sensors are there, right? So you can just check. These sensors are interconnected, by the way. They are giving you on your computer can see the what is the reading of it, or whether it is going to beyond the threshold, or it is not going, or what is the value of all the if these are in acceptable limits, then you are fine and you can visit. Otherwise, you can say, okay, no, I'm not going to go there because today the air quality is not good. And so like that, you see, the impact is very positive. And use of these sensors are very, very helpful in our day-to-day life, especially environmental monitoring as well.
Thank you so much, sir. You explained in very well and in chain like productivity, revenue, profit. So your answer is very
And
clear.
one more thing I would like to add here. So since you have mentioned, you see in chain, right? Like many of the items are prepared in the process, right? Industry is in sequence. So let's say 10 machines are working together in industry, right? And if any of the machines in between, if it goes into the breakdown, is it not that all the 10 machines are into the breakdown?
No, sir.
No, none of the machines will be working, even if one machine goes into the breakdown. Okay, so you see, if we can a priori know that, okay, this machine is going to go into the breakdown, we can immediately go and do something for that. Either we replace it by other machine if the symptom is that, you know, the machine is going to have some replacement or whatever. Otherwise, you know, by what means? By all means, basically, we need to make this machine working. It is exactly like, you know, many times we feel like feverish, right, or exertion or something like that. We either take rest or we take medicine so that our next day is fine, right? So this is exactly the same thing. So we are also working on condition-based monitoring. In fact, we developed the technology for Boeing industry, which is in use here, right? So on the same lines, so how was it implemented? Was based on the IoT. All the machines, almost all the machines are on the internet, and the devices are also on the internet, right? Thank you.
Thank you, sir. Thank you so much.
Thank you, sir. It was indeed a well informative session, and I'm sure all the faculty members and all the audience must have gained from it. Thank you so much once again, sir.
Thank you very much for patient hearing, everybody. Thank you, thank you. Thank you once again for inviting me for this talk. Thank you.
Thank you, sir. Moving on, I would again like to invite Dr. Deepti Sharma ma'am, Coordinator, School of Information Technology, to introduce our next subject expert from industry, Mr. PVN Pawan Kumar, sir. Ma'am.
Thank you, Ms. Pooja. Today we are fortunate to have Mr. PVN Pawan Kumar with us. Mr. PVN Pawan Kumar, Director of IoT Product Management at SAP Labs India, is a seasoned product management professional having more than 15 years of extensive experience in building products and working with global customers in emerging and developed markets. His expertise is in the area of Internet of Things, edge computing, sustainability, and analytics. Mr. PVN Pawan Kumar is an active contributor in the topic of IoT to Government of India and also with the industry bodies like NASSCOM, TIE, and the Standards Working Group like IEEE, NSDC, NASSCOM, IoT, SSC. He has recently co-authored a book on IoT and edge computing. Mr. PVN Pawan Kumar has been recognized as IoT Thought Leader of the Year at national level by IET India. Very recently, he made his place into top 25 influencers list globally for IoT published by analyst firm Analytica. Now, I request Mr. PVN Pawan Kumar to embrace the event with his knowledgeable words. Sir, please.
Hello, is it audible? My voice is audible?
Yes, sir.
Yeah, okay. Let me also share my screen. Right? Hope you guys see my screen.
Yes, sir.
Yeah. First of all, thank you, Professor Bhavana, for inviting me, and humble with the introduction from the Dipti as well. I'm excited and feeling extremely honored to talk in front of Padma Shree, Dr. Mahesh Verma sir and Professor Nishchal Verma. It was very informative sessions from both of them. So I'm now feeling challenged actually to speak in after them, right? I mean, that's very difficult, yeah? Okay. Now, let me justify my title of IoT is the new IT. I mean, since I'm coming from the background of industry, I would like to give an industry flavor of IoT, okay? So as you see there, right, in every business or an organization or a university, whether emerging or mature, right, has IT landscapes. And these IT landscapes cater to multiple processes, be it your attendance management or a travel booking or a settlement, replenishment process, procurement, etc., etc. Right. Now, what we are doing is IoT, the IoT signals coming from the sensors are getting embedded into these processes, and these particular processes are becoming intelligent. So in a way, what we are seeing is these IoT IT landscapes are evolving towards the IoT landscapes. That's what I mean by the title of the session. Okay. Now, what I'm going to cover today is in a nutshell, right? I mean, quick introduction. I think ma'am already did a great introduction, so I'm skipping that part of it. And the context setting about the IoT and different flavors of IoT. And Dr. Nishchal Verma sir covered very nicely and very thoroughly, many details. So what I do is I try to slightly change my content. Because I don't want to repeat certain content, but I try to give a different flavor to it. Okay. And then I wanted to say how, when I kept on saying like embed IoT, what does it mean by? And also the edge processing and edge computing. These are the topics I'm going to cover primarily from the industry perspective. Yeah, this is what I would like to cover today. Okay. Now, again, industrial revolution part, I will not cover much. If you look at the evolution of the technology through the time, we saw first industrial revolution facilitated production, and the second one facilitated mass production, and the third one facilitated automated production. And finally, the fourth one is facilitating higher productivity with superior experience. I mean, I recollect Mahesh Verma sir mentioned about this personalized experience as well. I'll touch upon that in the coming slides, right? I mean, now, if you look closely at the transition from the third to fourth stages of industrial revolution, right, you can see that internet straddles both of these eras. And one of the main proponents of the fourth revolution is Internet of Things and the connected world phenomena. Now, if you look at the IoT era, we have seen internet, which helped in the dissemination of the content. We have seen we have seen Internet of People with the advancement of social networks, where people talking to people via Facebook, WhatsApp, and all. And now we are seeing the Internet of Things era, right? So if I need to define Internet of Things, right? I mean, already Nishchal Verma sir explained about it. And since Mahesh Verma sir is from the medical background, I thought of taking an analogy comparing with the human body. Yeah, I mean, because again, giving a definition of IoT may be a repetition for you, right? So let me explain IoT more by taking the analogy of a human body and how it functions. If you look at a human body, all parts of the human body are equipped with different senses, such as touch, sight, hear, smell, and taste. Then there is a concept of communication, right? I mean, data coming from the senses, like when I see something, that will be transmitted via nervous system to the brain. Now, what brain does it stores the data, which is your memory, contextualize the data, and then also analyze with historical data and derive the conclusions, and also predict on how to react towards upcoming data streams, right? I mean, when I'm seeing something, eyes doesn't decide anything. Eyes transmit, and then the brain does everything behind, and right? Yeah. Now, next, there is a concept of control. When let's assume we are running and we see an obstacle in front of us, which makes our brain come to a conclusion that this is the right time to jump. So that means the brain remotely controlling our actuators. So Nishchal Verma sir touched about actuators, right? Exactly the same thing. The brain, controls our actuators, which is nothing but our legs, and execute us to jump, right? Assume I fell down and I feel pain. So brain instructs to send us to a doctor. Correct? This is how the human body works. Now, IoT also starts with the concept of sensing. Machines are all equipped with the different sensors, which sense the environment, just like our five senses. If you take a smart machine in any industry, right? I mean, they are embedded with lots of sensors, and these sensors sense many different capability parameters like temperature, vibration, etc., etc. And they send these data to the central processing unit, let's say some cloud or processing unit. Now, this processing unit would recognize a pain in the form of a failure data pattern coming from the sensor data, right? And then trigger a service request in the backend ERP system so that, a service technician go to the machine and repair it. Now, if you look at it, the concept of thing to data, I mean the device to data and data to insight, I'm getting some insight, and insight to action, that derives and defines the Internet of Things, right? This is how I wanted to explain IoT in a slightly different way. Now, I see there is a slight difference between human being and as well as IoT here. There are a couple of differences I can talk about. One thing, there will be far more than 5 sensors with IoT devices, right? I mean, we have 5 sensors. IoT devices can have lots of different sensors. I mean, hundreds or thousands of different sensors it can have. Yeah. And other thing is, if you take sensors, unlike our eyes, they can have a local storage and local processing unit. I hope you get what I mean by when I see something with my eyes, they don't have any processing. They just see something. They see some data, some picture that will be transmitted back to the brain for processing. But eyes will not have a local persistence or a local processing. So with the concept of edge computing, a small processing and a small storage is equipped with the sensors so that processing can be done at the place where the data is getting generated. This is what we call it as a edge computing also. Now, if I need to take one more analogy, right? I mean, edge computing is more like your subconscious mind. It will take care of your routine within the constraints of the known. Whereas the cloud IoT is more like a conscious mind, which will watch out for the unknown, requiring superior brain power. Yeah. Moving on to the other one, right? I mean, already Nishchal sir mentioned about IoT is there for quite long. And people considered it as ATM in 1970s was considered as the first IoT object. And sensors are there already in industries for many years back. But IoT, the terminology has been coined by Mr. Kevin Aston in 1999. Like he already mentioned, right? I mean, 1999, this particular terminology has been coined. Now, if the technology already exists earlier, why are we talking IoT in the current decade? It's because of the affordability and the scalability. It's not only about the feasibility, but also affordability and scalability, right? So if you look at in the slide, right, I mean, the sensors are getting cheaper day by day. In the past 10 years, the cost of processing has come down by 60 times. And I still remember someone is saying in one of the country, the aloo chips are quite expensive than the integrated chips. That's the reality actually, and that's the level of cost has come down. Now the connectivity also cost has been come down. I still remember paying for the outgoing calls many years back. Now we can watch a video in the mobile itself for free, right, or for a very small price. And unique identifiers, like Nishchal sir mentioned, everything is getting connected day by day. Alarm clock to the industrial machine to everything, right? And with that many connected things, we need to have unique addresses with IPv6 availability, which can cater to 350 trillion to trillion to trillion unique addresses. That many addresses, we can never run out of it. So IPv6 is also one of the enabler. And of course, the mobile availability. So what analysts anticipate is by 2025, 8.8 billion mobile connections will be there. Okay, at the end of the day, all these things will generate huge amount of data. Someone has to store that, right? Like you buy so many clothes, you need to have cupboard as well, correct? So with the advancement in big data analytics coming from software companies, I mean, that is also becoming one of the enabler. With that, what analysts predict is by 2025, 75 billion devices are going to get connected, and they're going to generate 44 zettabytes of data. creating 11.1 trillion economical impact. If you recollect Nishchal Verma's presentation, he nicely articulated about by industry, how much is automotive, how much is aerospace, how much is oil and gas, right? That is all when you aggregate, it comes to 11.11 trillion economical impact, yeah? Now, if you look at how IoT is pursued by different individuals, IoT is consumed by different individuals, right? Now, based on the adoption, I would like to classify IoT in the following way, what you see on my screen. So IoT is pursued differently by each individual. For some of them, it is as simple as a Fitbit, which can track the health and wellness. For others, it is as complex as remotely monitoring hazardous environments like oil and gas, or a connected train, or a connected aeroplane. Yeah. So it varies from a Fitbit to a connected aeroplane. Yeah. I mean, that level of diverse adoption is there. If I look at the number of IoT use cases, they are classified by consumer IoT, which is something like your smartwatch, smart home, etc., wherein the IoT is used by one single individual. The next one that it comes is the commercial IoT. Right, next one is a commercial IoT. Let me explain commercial IoT slightly different way than what was shown here on the slide. Right, imagine that you're going on a long drive in a car. I mean, hoping COVID is all getting settled, and then we happily go on a long drive in a car. And you stop as you refill your car at a fuel pump. Your fuel pump would connect to your car dashboard, and the retailer of that petrol bunk, right? I mean, he will push a offer or a discount on a soda or a drink or a snack or a chips pack on your dashboard or on your mobile. Now, also, not just that, based on the sensor data that is coming from your car, the manufacturer of the car can predict whether the car is going to get into trouble and inform them upfront, saying, hey, your car is going to get trouble. I mean, why don't you drop it at the nearby service station located in under 10 kilometers? Yeah, that kind of a thing will happen. Not just that, the insurance provider can adjust the insurance premium based on the driving habit, which is calculated based on the data coming from the sensors, like how fast I'm driving, how often I use the brake or the gear change and all. I'm not a great driver, let us say, and someone else is a great driver, but we use the same car. Why both of us should pay the same premium amount? If I am not a great driver and if I abuse the car very badly, then I should pay more premium than the other gentleman who drives nicely, correct? So that we call it as a driver behavior based insurance. And all of these use cases, right, more or less is available in one or other country where we have implemented. And touching upon this one-on-one hyper context coupon, this is something which is what Professor Mahesh Verma sir was referring to, right? I mean, now, I mean, if I open a newspaper, I might see one ad saying, hey, why don't you buy this? I don't care. I don't want to buy jeans at the moment. I don't even wear a jeans, let us say. So it's irrelevant for me, correct? Now, imagine I like jeans and I'm walking in front of Levi's store. I just gone out to buy some clothing and I'm walking in front of Levi's store, and Levi's pushes an offer to me saying that, Pawan, I know you are a loyal customer to Levi's and your friend Mr. James has purchased Levi's jeans 10 days ago and he gave a nice feedback. Why don't you buy it? Don't you think it's a hyper context sensitive coupon to me and I'm going to offer you some discount on it? That's exactly what we were trying to do a few years back, which we call it as one-on-one hyper context coupon. Like that, there are multiple commercial IoT use cases we can talk about if we are allowed with a lot of time. Yeah. And then industrial IoT, which is very serious in nature. I mean, like you have smart grid or a very tough environment like an oil rig or aerospace. If you take an aeroplane like an Airbus, I mean, 8,000 to 10,000 sensors are going to be with one aeroplane. If you take a smart watch or smartphone, which belongs to your consumer IoT, which will have 8 to 10 sensors, whereas an aeroplane will have 8,000 to 10,000 sensors. I'm working with one of the train company in Europe, and each train has 5,000 sensors sending data every second. Yeah. So they're very serious use cases. And finally, the smart manufacturing. If you look at a Harley Davidson bike, right? Harley Davidson bike is quite popular for customized bikes. Okay, what they did is they're very visionary and they're forefront of this industry 4.0. So what they did is they kind of connected every machine in Pennsylvania plant, and they in one production line 1700 plus bike variants can be made in one production from one production line. That is what it means by is a variant which is specially made for you. This is also exactly the point Mr. Mahesh Verma sir mentioned about. Someone wanted a particular object manufactured for you alone, right? That's exactly is what it means. They call it in manufacturing terminology, they call it as lot size of one. So now, not just this production line equipped with sensors can generate 1700 plus bike variants. The lead time for the production has been reduced from 21 days to 6 hours, which means I can go walk into the shop or I can go to the website and say, hey, I want so-and-so Harley Davidson bike with these customizations. Within 6 hours, my bike is ready. Earlier, it used to take 21 days. So it's not about the speed. I mean, I can wait for 21 days. It's more about how optimized are we running the production, right? That's one example. Yeah. So moving on to the different technology layers that form the enterprise IoT platform. Now, if you look at hardware, right? I mean, hardware, or we call it as operations technology, or also we sometimes call it as a hardware. Right, the hardware has got a device, and device is equipped with different sensors: electricity or a location, vibration, pressure, etc., etc. Right, that is one way. Scientifically speaking, right, sensors are the transducers. In one form, they sense the environment and send the signals. In another form, they receive the signal to act and activate. For example, in a smart home, right? I mean, sensors detect when there is someone entered the room, and the actuators get triggered to stop a heating system or a switch on the AC. Right? I mean, that's the difference between your sensors and actuators. Now, that's when the connectivity layer comes into picture. Ms. Pooja has asked a question about communication layer, right? Now, this communication layer is extremely important, and that plays the role of glue between your hardware sensor, hardware device, and the software platform. Okay, and this can be further classified into 3 layers. One is your physical layer, which is Wi-Fi, Bluetooth, LoRaWAN, Ethernet. Depending upon the use case, you pick up one of them, 5G, whatever, right? And then the other one is about network layer, which we talk about IPv6, OPC, Modbus, these are the network protocols. And finally, the application layer, how you send the data to application via HTTP protocol or MQTT protocol, co-op, or whatever, right? I mean, so fundamentally, the communication layer, what you see here, acts as a glue which picks up the data and send it to the software platform, right? The next part is software, information technology, or the software layer. Now, there is an in-between agent, which we call it as a device connectivity. Now, the hardware world generates the sensor data. The software world has to understand, first of all, authenticate this device. Someone asked a nice question about security, correct? So first, in order to ensure, am I allowing a right device to send the data? First of all, this particular guy, device connectivity, has to authenticate the device and get the data into the software world. That is the job of device connectivity layer, which we often call it as a gatekeeper, right? I mean, gatekeeper who ensure right person is getting in, right, in a similar way. Now, once the data enters to the software world, we have heard about the world called digital twin, right? I mean, which is a digital representation of your physical device. Okay. Now, this digital twin a kind of a representation of the device and tells the software system, hey, you are going to expect data from a device like this with certain sensor values, right? Now, I also touched upon one example of a train, 500 trains, and each of the train having 500 sensors sending data every second. Imagine that. Huge data, right? So you need to have a queuing mechanism to take the data into your software. I also worked with one of the retailer who connected 5 lakh refrigerators across Europe. Now, all these 5 lakh refrigerators sends the data throughout 24 hours, maybe once in 5 minutes. Now, we need to have an efficient queuing mechanism to get the data into the software, right? That is what handled by your ingestion pipeline. So the first one is the device connectivity will authenticate the device and sensor and allows the data in. The digital twin kind of validates it, and the ingestion pipeline will process and put it into the queue. There are technologies like Kafka, Spark, and many others are available, which helps in making this ingestion or queuing mechanism very efficient. Now, okay, data is coming, all that. We need to store somewhere, right? Then we are going to have an element called big data storage. Now, with the big data storage, Big data, what happens is it can persist the data in a tiered way. For example, you have lots of clothes in your home, right? I mean, the one what you wear so frequently on a daily basis, you keep it at the nearest cupboard. The one which you wanted, but you wear maybe once in 1 week, you keep it a little farther cupboard. The one which you wear only for occasions like a festival or a marriage or something, you keep it somewhere on the cupboard on the top. Right? In a similar way, the huge data, I'm going to get it from the sensors. I can't keep the data in the same and treat it in a similar way. I need to have it in a tiered way. So we have 3 different ways of storing the data in the big data store. One is your hot store, which is whichever you want urgent, you keep it there. Warm store, medium frequently accessible data, and a cold store, which is like your archive data. So that big data management is also needed in the IoT infrastructure. And then you have this data, but you need to contextualize the sensor data. Say I'm getting a temperature value like 10 degrees. Is it high or low? I don't know. If the temperature is in a refrigerator, it is high. Refrigerator has to work much less one, right? If it is in a microwave oven, it is low, correct? It has to heat my food, correct? So whether it is a refrigerator or whether it is a microwave oven, that is the context. That context is not provided by your sensor. That context is provided by your business system. That kind of an information is blended with the sensor data. That is why I called it as a contextualized sensor data. Now you have the data, you stored it, you contextualize this, then what is next? I need to find anomalies. Simple. I wanted to find some anomalies. If there is a problem, I want to take an action. That's what your rules engine is all about. Or I wanted to develop an application or a predictive algorithm or an ML algorithm. Yes, you can do. So these are fundamentally the layers that are available in the entire enterprise IT OT world. Yeah. Now, probably I can skip this one given the time frame, but just in a nutshell, if I need to cover, your IoT platform can get potentially data from devices directly, or it can get via the edge computing platform, or devices can send data via telco clouds, which is becoming very popular with many of the enterprise IoT implementations. Many of the companies, right, bigger companies, they just give the contract to the telcos, and telcos means typically like your communication companies. And what they do, they IoTize the devices and they get the data and they transfer the data to IoT platform. And then in the manufacturing environment, you see with OPC kind of thing, data coming from PLCs, SCADA, historians kind of systems, right? And on the other side, you also get the data from the backend business systems. Like I mentioned already, you need the information about any asset will be stored in the business systems, and you blend here, and you then finally build an application like your cold chain monitoring for vaccine. When COVID vaccine comes out, we need a cold chain monitoring or a manufacturing or a smart city use case, etc., etc. Or I can use this data for building analytics for analyst user, or I can use it for machine learning for data scientist. Now, I talked about embedding IoT intelligence into business process. Let me quickly show you one example. I mean, whatever the examples I'm quoting are all the real life examples where I worked with. Yeah. Now, there is a company, I anonymize the name. There is a company called FruitSync. What this company does is this company fundamentally produces jams, syrups, and also artificial flavors like orange flavor, mango flavor, and all. Okay. They need raw material like sugar. They get sugar from their suppliers, right? I mean, suppliers send the sugar via truck and then it put into a silo, and this is consumed while in the production process. And the sugar is processed along with the fruits to prepare a fruit product, let's say a strawberry jam or a strawberry flavor. Once this particular product is made, this is put into the containers, small containers, right? And then, or in a truck, tanker truck, and they send it to their customers. Today they may send it to maybe Pepsi, tomorrow they may send it to Coca-Cola, and day after to someone else, right? I mean, this particular company has multiple customers. What their customers do is they again further process it. Like if I take an example of cola, they may make orange soda, or if it is here strawberry jam, they mix with curd and then they make a flavored curd, and they finally sell in the retail store. This is a standard business process for this company, and not for this company, for many such companies who are into F&B. Okay. Now, what is the problem this company has? Let's look at it. Right. So they have the problem with the replenishment. They wanted to ensure the silos where they keep the sugar should never run out of it. If they run out of it, they get into the production become halted, and they lose, they incur a lot of loss. At the same time, they wanted to ensure their customers should get the product in time, even before they ask for it, they wanted to supply based on the consumption. So these are the IoT-ized business processes that I can call. By embedding sensors, the silos and the containers and tanker trucks and everything, right, in the entire process, these are the use cases that were optimized. One is monitoring the product fill level. How is the sugar? How is the product, right? And based on the consumption rate, it's not just about monitoring how much is left in the silo. It's also about how quick I am consuming. Maybe I'm left with 10%, but that 10% I consume in under 1 day or 1 minute, right? I need to know the consumption rate before I automatically trigger a replenishment order to the supplier. And automatically stock corrections, right? When the supplier go on refill again, you sometimes supplier on a paper, you may ask for 1 ton, but in reality, it may be 990. That kind of a corrections can be made before you pay to the supplier. And of course, the monitoring the temperature and humidity and other storage conditions to ensure the raw material is in right state. And the email alerts whenever there is a problem. So these are certain things. If you take container, an additional use case is beyond the replenishment, track and trace, ensuring that container is spending less time in transit and more time at the customer. And sometimes these containers get lost. Okay, I mean, ensuring these containers are not getting lost with geofencing alerts and other things to control the such things as well. And one important thing is dynamically adjusting the expiry date based on the storage condition. This is a very simple concept, right? You buy a milk and you keep it outside instead of fridge. You consume quick, right? You're dynamically, adjusting the expiry date of the milk. Milk will expire in 2 days if you put in fridge. Otherwise, it will expire in 1 day. You're consuming quick. In a similar way, if this particular container is not maintained properly throughout the supply chain, I wanted to dynamically reduce the expiry date or adjust the expiry date of this particular syrup so that end consumer like a cola or a Pepsi will not get affected. That's one of the important use case. And also, if you look at the vaccine or any other pharma kind of a thing, it's extremely important. You have to maintain these vaccines and other pharma in the right temperature when they are across the supply chain. Okay. Now I'll go with another one called extending the business process to edge, which is primarily the edge computing. Okay. Yeah. So if you look at just a moment, time check. Bhavana ma'am, do I have another 4-5 minutes? Is that okay?
Yes, sir.
Okay, fine. Yeah, thank you. Now, we talked about embed IoT into the business process and how can you make processes more efficient in the earlier slide, right? And also, I also recollect one of the questions from Ms. Pooja Bisht or someone, right? So asking for, hey, how it affect sustainability as well as environment. Now, I'll take one more example. Imagine there is a vending machine in your campus, KCC campus. Vending machine vends Coca-Cola bottles. Okay. Now, the last bottle is getting vended. So obviously your sensors in the vending machine can tell, hey, this is the last bottle. I should quickly reorder. Okay. Now that is a standard automatic replenishment process. The sensor will tell this is the last bottle. Automatically a purchase replenishment order is triggered in the system and the supplier will supply. But why don't we apply some intelligence to it? Okay, an event is ongoing right now. There will be too much of consumption of cola bottles. Why can't I order so quick, or why can't I get quickly bottles from a truck carrying surplus cola nearby me? Like imagine there is a truck of Coca-Cola which is going nearby, which is not intended to come to this particular vending machine, but to another machine. But because of all this connected phenomena, this particular vending machine, no, it has got surplus cola. Why can't I inform the truck driver to deroute and come here and refill here because of the urgency? That is an intelligent replenishment, right? I'll take another example, right? Let's imagine today is a Friday end of the day, and tomorrow and day after is a public holiday, no one will be in the college. Then in that case, why can't I delay the processing of replenishment? There is no urgency. No one will be in the college in the next 2 days. Whether I refill today or Monday, it doesn't matter. So why should I waste a trip for the truck coming on Sunday? Typically, what happens with this replenishment is truck goes in the morning and the evening, check the status and refill. Now, in a way, you are optimizing the process, right? Number of trips of the truck is getting reduced. In a way, the company is saving money. Another way, you are reducing the number of trips, also reduces the fuel consumption, which in turn reduces the carbon emissions, right? That's an example. So coming back to enabling IoT to scale with edge computing, right? Why do we need edge computing? Why do we need edge computing? See, these IoT devices generates hell lot of data, lots of data. Sometimes it's expensive to even store, transmit over the network also. One of the use case while we are doing research with one of the car company, we realized that IoT will generate in the next 10 years for that company only exabyte scale of data, an exabyte scale. And exabyte scale, if I transmit over internet to cloud, it will consume almost entire bandwidth of India, network bandwidth of India, or 1/10 of European network bandwidth. So it's one use case I'm talking about, right? So sometimes it is important that, you no need to send all the data to cloud. You need to process it at a location where you are generating the data. The second one is intermittent connectivity. So if you take a ship getting into an ocean, or if you take an oil rig or a mining, you don't get a network signal, right? So, but it is important that you need to still process. So in case of intermittent connectivity also, you need to handle certain use cases. I'll explain one later. And the real-time decision making. Sometimes we can't afford to have a one round trip to the cloud. Your sensor will identify some anomaly. Sensors identify the data and send it all the way to cloud, and the cloud identifies the anomaly and instruct back to the device to do something. In that case, I can't afford to have a round trip in some of the examples. One practical example, some years back, we were supposed to show a vending machine to former US President Bill Clinton. Okay, before he arrived at the space, one of his security personnel came and he swiped his card to buy a cola bottle from the machine. You know what happened? He swiped the card and cola bottle arrived after 5 minutes. In that case, it is not a mission critical. But imagine the similar situation in a mission critical case like an oil rig or a mining, where some accident can happen, or a train or autonomous cars we are talking about, right? In all these cases, it's a mission critical as well. In this case, it's a loss of reputation. The vending machine brand is going to lose the reputation, and this guy will never ever come to this vending machine and buy any product, correct? But in other cases, there can be a possibility of losing lives as well. So real-time decision making is sometimes important because of all these three reasons, right? I mean, edge computing is sometimes needed, where you move the processing from the cloud to the edge. Okay, now what is edge? Edge can be a vessel in the sea, or an oil rig, or a retail store, or a train, or a bus, or anything can be an edge. Okay, technically speaking, from a hardware perspective, an edge device can be a dedicating computing device, something like or a rugged device, something like Cisco gateway or a remote server, industrial PLC, or even Raspberry Pi can be your edge computing device. Yeah. Now I'll take one last example on the edge computing per se. So there's a shipping company in Europe. Okay, this particular shipping company, what they do is they have close to 250 shipping vessels, and they have 5,000 seafarers. Okay, and these ships are on voyage for almost 8 months in a year. And when they are in the ocean, they rely only on the satellite connectivity, correct? But satellite connectivity is always reserved for the critical vessel operations. But during the voyage, what is needed is the crew members need to purchase bonded materials on the ship. Also, they need to do some cash advances when they go to a local port and buy certain materials like telecom cards, medical stuff, or a vessel operation maintenance stuff like ropes, spare parts, etc., etc. When this ship goes to the shore in between, they need to do all these transactions. In order to do all these transactions, they need to have an ERP system in the ship, right? Or at least they need to do all that, right? But there is no signal. In that case, what edge computing does is, you do all the process when there is no connectivity, and when the connectivity is back, you synchronize with the cloud and send the data. It is something like you do offline document. When the connectivity is back, you upload back, right? In a similar way, that is something we call it as extending your process to even at the edge. There's one more classic example where in oil and gas and environment, right? I mean, typically, mining environment, typically the people are exposed to poisonous gases, toxic gases. And when they are exposed to gas, they might fall down and there will be no one. The sensors which are associated with the gear, what this guy wear, will immediately identify there is a problem of the toxic gas and this guy fallen down, and automatically update and create a service request and automatically create alert in the systems within the intranet. So this is very unique. You can't rely on the 5G or a 4G or a 3G or a Wi-Fi there in a mining environment, right? Yeah, this is also one of the example of edge computing. In a similar way, and finally to conclude, right? I mean, enterprise IoT is adopted for 4 different reasons. One is your situational awareness for step change in productivity. Nishchal Verma sir nicely covered this one. You need to improve the productivity. By embedding sensors, you can do lot many use cases, okay, which we already discussed about this particular fruit sync company. And how do you improve the customer experience? So imagine you have I mean, there is a company which is which has a equipment, okay, this particular equipment is getting into trouble. Because of the sensors, this particular company was able to already predict this problem, and then even before the customer complains, they send the technician to fix the problem, and the technician will have in the mobile all the data what problem might have happened, right? Do you think the customer will be happy? Say I have a battery in my home for inverter reasons. Imagine a service technician comes to my home and says, sir, your battery is going to you know, dry down or getting into problem in under 1 day. We observed that with the sensor data, and I know the problem as well. I'm fixing it and going back. Do you feel super good with this particular company? That is what is super customer experience, superior customer experience. And also consumer engagement also will be improved with the IoT. Those are some set of use cases. The next one is getting into a new business models as such. Nowadays, companies stopped selling the products for some of the cases. For example, in one of the company in Korea, right? I mean, they used to produce the air purifiers. Okay, basically they used to produce air purifiers, they embedded sensors, and they kind of started selling to the customers. So off late they realized, hey, I have already all the data about air purifier. I know how much purification is happening at his home with this purifier. I know when the filter has to be replaced. Why can't I sell purified air as a service instead of selling the purifier? This is exactly what started in Korea, where we worked with, and they initially started to predict when they need to replenish the, you know, or refill the air filter. They ended up in converting to something called purified air as a service. Even in India, one of the company, what they do is instead of selling water purifier to your home, they charge you based on the number of liters of water you drink. They're getting into that business model. Okay, so purified air as a service, purified water as a service, compressed air as a service, these kind of business models are quite becoming popular nowadays. And finally, extending business process to edge, which I already explained in the earlier example. So with that, I would like to conclude my session. And what I'm trying to tell is IoT is going to benefit a lot industries, people, organizations, and everyone. Of course, there are security concerns, privacy concerns that are there. I mean, as technology evolves, all these concerns evolve. When internet came in, we observed the security and privacy concerns, right? When the social networks came in, there also the security and privacy concerns came in. I mean, the theft, earlier the thieves used to go and steal the house by breaking the door. Now what they are doing, when I update in Facebook saying, hey, I'm going out of station, then they'll come and steal the house, right? So with everything technology advancement, there is a problem with the security and privacy gets into the picture. So that needs to be taken care, obviously, with the technology advancement. With that, I would like to conclude my session, and thank you everyone.
Thank you so much, sir. If you may allow, we have few questions from our audience.
Sure, definitely. Yeah.
Thank you, sir. Saraswati, you can go ahead.
Thank you, ma'am, and thank you so much, sir. You shared a very good knowledge with us. It would really help us in the future. Thank you, sir. So I have few questions. So my first question to you is that what are the impacts that can be observed in implementing the Internet of Things on the agriculture sector?
See, first of all, IoT can be applied to any use case. Okay. First of all, say I'm keeping a water glass near this laptop while I'm giving session. As and when I drink the water, water gets over. I mean, if an alarm is getting ringed in my home, that's also an IoT use case. Now the question is, by implementing IoT for this scenario, what I explained just now, does it have an economical value, or does it have a, I mean, the commercial value or environmental kind of an impact, or any other impact should be there? So similarly in agriculture, right? There are some, I mean, I have seen one of the use case wherein, you know, what I observed is, which I never know in the past unless I came to discussion with that use case. There's a lot of water gets wasted in the while growing the rice. We don't know how much water is needed. Water is always get pumped and then get wasted. What if we have a system in place which can detect the moisture? It's not about rice growth needs water. It's more about the moisture levels and many other parameters. If we rightly know those parameters, and a kind of, you know, sensors can help you to identify that and then control the water flow, that's an IoT use case. Like that, there are multiple IoT use cases that came up in the agriculture domain. People used to call it as a smart agriculture and all. Geofencing, like fencing the units when any animal is entering into the field, sending an alarm, water conservation, electricity conservation. Many of such things are coming into picture in the agriculture area. But again, what we need to always conscious about is the cost of the implementation. Okay, I spoke to one of the very big vendor in India for a cooler connectivity. And then I told, sir, we can connect all your 10 lakh coolers, what there in India. Is a beverage company. Okay. Then he mentioned, boss, can you do with 100 rupees investment on the sensor per cooler? So it is extremely important to balance the cost with the output of it as well. Yeah. Hope it answers the question.
Yes. So the answer was very clear. Thank you so much, sir. My next question to you is that what are the skills or expertise that someone must learn or must possess to be successful in the IoT fields?
There's nothing like a specific IoT skill. It's IoT is an ecosystem play. Like I can't say, oh, a company like SAP alone can do IoT, nor a hardware company or a telco company can say they can do alone IoT. So IoT has got three aspects. One is your sensory technology, right? The other one is a communication, like Pooja ma'am asked about it. The third one is about the software world, the big data systems. I mentioned about how do you manage huge data. And the fourth one, you have all the data. Someone has to analyze. I mean, artificial intelligence, machine learning, prediction, all this comes in. These are the four different areas. So it is nothing like, I need to learn all the four of them. Okay, based on the interest levels, based on the situation, right? I mean, you can get into one of these things and learn and get into the IoT implementation overall. However, you need to have a very good grasp of how end-to-end works. Again, very silly example I can quote, which happened in real time for us. We designed a nice, very nice use case for one of the costliest perfume company. And I went to a customer 5 years back in Europe, and they're going to keep perfume in a container. Okay, small container, and that container costs almost like a few lakhs of money. And you know what? We already imagined that there is a sensor which can sense the flavor of the perfume. But in the world, is there any sensor that exists which can smell the perfume? No, except for our nose, right? So without having the knowledge of what sensor technology that exists, what sensor exists, we build the use case and pitch it to the customer. And when we started implementing, we figured out, oh, there is no sensor that exists which can tell whether it is a cologne perfume flavor or something else, right? So an end-to-end grasp is extremely important, but you can focus on one of the vertical areas like I mentioned. Hope that answers. Yeah.
Yes, sir. Thank you so much, sir. My next question to you is that what would be the impact of Internet of Things on the jobs?
The jobs, there won't be impact. See, when the technology was, nature of jobs gets changed. Let me take a bank example, right? I mean, now earlier, when we go to a bank and try to withdraw, the application goes from one step to other step to other step, right? 3 steps or 4 steps. Now it can be done with one entry in the system, but then that job might have, that particular operation might have vanished, but a new job came into picture where they need to maintain this in the ERP system or some other financial system, right? So the nature of job will change with the technology involvement. There is no risk to the job as such. Okay.
Yes, sir. Your answer was very clear and you explained it really very well, sir. Thank you so much, sir.
Sir, I have one question. Can I
Yeah,
ask?
sure. Yeah, sure, Tina.
Sir, so my question is, do the IoT devices required any specific operating system? Which operating systems support most of IoT communication?
Okay. So I'll kind of split this question into two first of all. There is nothing called IoT device per se exists in the market. Okay. So it all depends on the use case. Okay. I wanted to do reverse osmosis monitoring. If you, you know about RO process for the water treatment plants, right? No, I wanted to, predict when these membranes are getting failed in the RO plant. In that use case, the device is going to be your RO machine. Okay. Now RO machine doesn't come with the sensors by default. You are going to glue the sensors to it. Okay. There is nothing like a specific IoT device that exists. Okay, like I gave one another silly example of water bottle beside my laptop. When water levels go down, there should be an alarm. Now, this is the use case I wanted to implement. I'm crazy about it. Now, in that case, for that water bottle, what and all is needed? I need a fill level sensor. I need a temperature sensor to monitor the temperature of the water. And I need a small gateway kind of a thing which can transmit the data via SIM card or a Wi-Fi to application, right? So I need to glue them all together to the water bottle. Then that becomes your IoT device. Got it, right? So there is nothing like a ready-made IoT device that exists in the world. Based on what do you want, you put. The more intelligence you want, the more sensors you put. Like I gave the vending machine example, right? There is a cooler example, refrigerator. One of the beverage company in Vietnam and all, right? They told, hey, we wanted to monitor these coolers because the coolers are getting stalled. You know about this Coca-Cola kind of a coolers, right? Small things, coolers they're getting stolen. So what we told is, why don't you put a beacon and then monitor the location? Very cheap solution, which came up to somewhere around 50 rupees, 500 rupees per cooler. They told, no, I also want to monitor the products that are kept within the cooler, temperature and all that. Then we put a temperature sensor and all, and cost increase it to 1000 rupees or 2000 rupees. Then they told, no, I also want to scan the cooler planogram itself. If you look at some of our coolers in India, right? If it is a Coca-Cola cooler, you see Pepsi bottles in it, or you see coriander, curd, paneer also in it, right? So what happens is the cooler is getting misused there, correct? So you can put a camera and watch the planogram of it. Then we started inserting much more sensors, which started giving costing around 10,000 to 15,000 rupees. Then they come back and told, no, we want to keep coolers in a 5-star hotels wherein they also need to identify people and put offers. They can play games on it with a touch screen is there. They can play game on the cooler and all that stuff. We told, yes, that is possible. We embedded few more sensors. So if you look at it, what we are doing, initially this particular cooler is a dumb and shy device. If you go and hit with your leg also, it doesn't do anything, right? Now later you embedded beacon for location monitoring. Later you embedded temperature, pressure, some other sensors for health monitoring of storage conditions monitoring. Later you put one camera to monitor the planogram. Later you have put camera, microphone, voice and everything to make it further big. So now what is IoT device? The first one is also IoT device, last one is also IoT device. Okay, one of the company, Coca-Cola, right? I mean, they came up with the nice concept, touch screen video for the cooler. Okay, they kept one in India, one in Pakistan. Okay, to promote the unity, what they did is, when you go and wave hand from here, the other person also wave hand on other side and smile. They both of them get a free cool drink, right? I mean, now here the sensors has to be so much. The device is going to be so expensive. Correct? What is your use case will drive what smartness is needed in the device. Hope that answers. Sorry for taking a long time, but yeah.
No, sir, it's absolutely fine. Thank you so much, sir. Thank you.
Yeah.
Sir, I have one question.
Sure, ma'am.
I have read that the implementation of IoT will take a lot of energy consumption. Will it affect its use in developing countries?
Okay, so implementation takes a lot of time is what we face the problem. Energy consumption, like again, I refer back to what Nishchal Verma sir mentioned, right? Energy consumption and carbon emission, they go hand in hand, correct? Now, what are we doing? The fundamental thing with IoT is you're automating certain things, correct? With the automation in place, the consumption will come down, ideally speaking. However, if you choose wrong components, say for example, like a water bottle example, which is not needed, I don't need, I can go down and pick up the water, right? If I implement IoT use such a thing, a very big components like a 5G, if I use it for it as a communication mode, okay, or a SIM card, you are wasting energy for such a small use case. Correct. Even for a refrigerator, if I put so many sensors, it's not needed. I can throw the refrigerator if it doesn't work, rather doing predictive maintenance for it, right? So it's all boils down to what is the scope of your implementation for the use case. Hope that clarifies, ma'am.
Yes, sir. Instead of saying that it consumes lots of energy, we can say if we are not using it in a proper way, wrong use of it will increase. Okay.
Yeah, if you don't use it in the right way, I put it in other way. There is nothing wrong, but not in the right way. If you don't use it, yeah.
Okay.
It is like, you are building, there is a traffic jam between your place and 10 kilometers from other place. If you are building a flight between these two, it doesn't help, right? You're building a complex solution there. Right? Yeah.
Thank you, sir, for sharing the multifarious applications of IoT in various industries, explaining how the whole process of sensory organs in humans is recreated in IoT, further making each one of us relate with the concept of IoT even more effortlessly, addressing the general concerns related to IoT. Thank you so much, sir, for this informative session.
Thank you, everyone, and apologies for not opening the camera because of, again, like I mentioned, network issues prevailing here for me. I mean, I didn't opt to switch on the camera. Thank you. Thank you, everyone.
We truly understand your problem, but thank you so much.
Okay, yeah.
Thank you, sir. Moving on, now I request Dr. Sunita Singhal, ma'am, Coordinator, School of Management, to present the conference report. Ma'am.
Thank you, Ms. Pooja. I would start with one famous quote given by celebrated scientist Stephen Hawking. Once he said that if we do discover a complete theory, it should be in understand by everyone, and it could be possible only if philosophers, scientists, and just ordinary people would be taking part in discussion why we and the universe exist. It is this idea that led to the genesis of this conference, with the firm belief that theories, innovation, and new ideas can be understood and improved upon if they are brought before an audience and discussed in academic platform. This one-day national conference, organized by the School of Information Technology, was structured to foster discussion between participants around the core theme OMNI-LAYER, dynamism, and IoT. For this conference, registration was open to research scholars, academics, and corporate delegates, and today, more than 30 participants are going to present their research papers in the plenary sessions, which are scheduled on Zoom. Works of all the presenters will be acknowledged by 2 layers of publication. All abstracts will be published in the conference proceedings, and selected papers will further get placed in Semantics, Journal of School of Information Technology. It's a matter of esteemed pride for KCC-ILHE to have Padma Shree Dr. Mahesh Verma sir, Honorable Vice Chancellor of Guru Gobind Singh Indraprasth University, as a chief guest amongst us. In his inaugural speech, sir talked about future aspects of IoT, digitization, and relevance of data. Sir is very positive and confident about willingness of human race to chase progress, and this willingness will definitely pave the ways for collective progress without compromising ethical paths. Conference is also graced by the presence of Dr. Nishchal Kumar Verma, Professor IIT Kanpur. Sir made the complicated terms related to IoT very easy for everyone. He talked about building blocks of Industry 4.0, components and functioning of IoT, and how it would become base for next information revolution. While answering queries, he also put emphasis on being always ready and updated algorithm to overcome any breach, which is always predictable. We also got opportunity to listen expert from the industry, Mr. PV and Pawan Kumar. He introduced several case studies and focused on affordability and scalability and optimization done by IoT. He covered its beneficial aspects related situational awareness, customer experience and engagement, establishment of new business model, and extension of business even in edge locations. In the nutshell, all the three guests of the national conference, with their enlightening address, which were filled with the novelty of ideas, radiated a source of energy within everyone participating in this conference. Session was full of enlightening inputs, and personally, it's very fortunate moment for me to share the screen with all of you. Thank you, everyone.
Thank you, ma'am. I would kindly request our chief guest for the day, Padma Shree Dr. Mahesh Verma, sir, and our esteemed speakers, Professor Nishchal Kumar Verma, sir, and Mr. PV and Pawan Kumar, sir, to join us for the vote of thanks. Thank you. Further, once again, I would like to invite Dr. Deepti Sharma, ma'am, Coordinator, School of Information Technology, to present the vote of thanks. Ma'am.
Thank you, Pooja. A very good afternoon to you all present here. I feel honored and privileged to get an opportunity to propose a vote of thanks. I, on behalf of KCC Institute of Legal and Higher Education, convey deep regard and heartily thanks to our chief guest, Padma Shree Professor Dr. Mahesh Verma, Vice Chancellor Guru Govind Singh Indraprastha University, for gracing the inaugural ceremony of National Conference on OMNI-LAYER Dynamism and Internet of Things. Sir, we are greatly encouraged by your gracious presence and immensely benefited by your inspiring address. We are extremely grateful to our invited speaker, Dr. Nishchal Kumar Verma, for being a source of encouragement and enlighten us with such a knowledgeable talk. We are thankful to our invited speaker, Mr. PV and Pawan Kumar, for giving his precious time and delivering a wonderful lecture. I sincerely thanks to the member of advisory committee for their valuable suggestions. I convey thanks to all the distinguished delegates for their enthusiastic participation in the conference. This reflects their commitment to the profession. Now, my special thanks to the member of organizing committee, technical support and other supporting staff for their dedication, teamwork and untiring effort. On our part, we have also made a sincere effort to enhance the quality of the conference. Thank you very much. Thank you all.
Thank you so much, sir.
Thank you, sir. Thank you, ma'am. Thank you, everybody, for being here today.